Another way to solve a system of equations is to do it by the substitution method. So in order to use the substitution method, so now the next two methods are going to be algebraic methods. So to solve a system of the equation with substitution, solve either the equation for one variable, and then we're going to substitute that into the following equation, and then we're going to solve like we would just a one variable equation. So in this particular problem, let's take a look at the first one. We're going to pick one of these to solve for one variable. I'm going to pick the first one only because the x is by itself. So I'm really just going to move this 5y over to the side. So in doing so, I end up with x equals 5y plus 13. So now what we're going to do is we're basically going to plug in 5y plus 13 into x here, and we're going to solve for y. So we'd end up with negative 7 5y plus 13 plus 8y equals negative 10. So we're going to go ahead and distribute the 7 to both of these, and we get negative 35y plus, or minus, because of that negative, minus 91 plus 8y equals negative 10. The negative 35y, sorry, and the positive 8y are going to combine, and we're going to end up with negative 27y minus 91 equals negative 10. We're going to move the 91 to the other side. We're going to end up with negative 27y equals 81. Let's go ahead and divide both sides by negative 27. And we end up with y equals negative 3. Now we're not done, because all we know is that y equals negative 3, so we need to go ahead and plug that back in. And so we're going to plug it into the first equation here. So we're going to say x minus, or actually, we're going to plug it into this one because this one's already solved for it. So we're just going to say x equals 5 times negative 3 plus 13. This is negative 15 plus 13. So therefore x equals negative 2. So therefore we do have a unique solution here, and our solution is the point negative 2, negative 3. We should double check our solution by plugging it into either one of these, right? But let's plug it into this one only because I use that top one to find negative 2. So if I do negative 7 times negative 2, that gives me a positive 14 plus 8 times negative 3, which gives me a negative 24. So positive 14 minus 24 does give me a negative 10. So check this out. All right, let's look at the next one. So in the next one, I'm also going to pick this first one, and I'm going to solve for y, because notice how y is by itself there. So that becomes y equals 2x minus 16. And then we're going to plug this in for y in the next equation. So we end up with 12x plus 5 equals 6 times our y value there. So here's our 2x minus 16. Okay, we're going to distribute the 6 to both of these, so we're going to end up with 12x plus 5 equals 12x minus 96. Okay, but now notice I'm going to go ahead and subtract 12x from both sides, and I end up with 5 equals negative 96. But that's not true. That's a false statement. So because it's false, I hope you come to the conclusion that we would end up with no solution. So in this particular case, we have no solution. So there are no two values that would satisfy both of these equations. All right, so in this next question, right, it's not as easy for us to be able to find an x or a y value that we can transform, but I'm going to go ahead and pick the x, and we're just going to end up with a fraction here. And so when I solve for this, I'm going to end up with x equals 2/3 y plus 10. So then this becomes 7. I'm going to substitute in for x, and I'm going to put in that 2/3 y plus 10 plus 5y equals negative 17. All right, so let's go ahead and distribute that 7 into everything inside of those parentheses. So now we end up with 14/3 y plus 7 times 10 gives me 70 plus 5y equals negative 17. So let's move the 70 over to this side, and I get 14/3 y plus 5y equals negative 87. All right, so in order to combine these two, notice that this is going to be 5 over 1. So I do need a common denominator. That common denominator is going to be 3. So then I end up with, and I'm going to come over here to this side, I'm going to end up with 14 over 3 plus 5 times 3 is 15. So I'm going to get 15 over 3. And I'm going to add these two numbers together. So I end up with 29 over 3y is equal to negative 87. Okay, so now what I can do is I can actually, I'm going to multiply by the reciprocal by 3 over 29 on both sides. And so then I'm left with y equals negative 9. Okay. All right. So I'm not done yet because I know what y is. So let me go ahead and plug that into our next equation, which is x equals 2/3 times negative 9 plus 10. So 2/3 times negative 9, this is going to be 3 times 2, which is going to give me a negative 6 plus 10. So then we can see that x equals 4. So then that means that our solution, we are going to have a unique solution, and our solution is when x equals 4, our y value is negative 9. Okay. All right. So our last one for substitution is number 8 here. And so let's go ahead and transform this first one again. We're going to go ahead and solve this for y. So when we solve this for y, we end up with y equals negative 4/3 x plus 7. Again, we're going to substitute that in. So we're going to end up with 5x plus 9. Whoa. Negative 4/3 x plus 7 equals 63. Let's go ahead and distribute that 9. And so we end up with 5x plus, and then a 9 times a negative, right? That's going to be a negative. So let me get rid of this. It'll be minus 12x plus 63 equals 63. Well, we can combine like terms here. So 5x minus 12x, that's going to give us a negative 7x. And then when I subtract 63 from both sides, I end up getting 0. Well, this just means that x then must be 0, which is always a nice number to play with. So now using this equation, let's go ahead and plug that in. So we get y equals negative. I don't know why my pen is dragging like this. Negative 4/3 times 0 plus 7. This goes to 0. So we're just left with y equals 7. So that tells us that the solution set is when x equals 0, y equals 7 is our answer. So that one is another example of a unique solution. So we had 3 here with a unique solution. We had one with no solution. So just real quick, because the difference between a no solution and an infinite solution is that an infinite solution would give us a quantity that is true. So here this is true. So then that would mean that I would have infinitely many solutions. Whereas a no solution would give me a statement that is false. So it kind of comes back down. So even though all your variables cancel out, it'll cancel out in both of these examples, but then you're going to say, is it the statement true or is it false? If it's a true statement, we have infinite many solutions. If it's a false statement, we have no solution whatsoever. All right, that sums up everything that has to do with substitution.